Okay, so this is another video for the Introduction to Limits section. And we're going to talk about what are called secant lines and then also difference quotients. Okay, and basically what you might be asking yourself from the first couple of things is like, where are these limits coming from? Like, I've been doing math for a long time and we've never talked about limits. Like, this is kind of crazy. Why am I doing this? So this section is a little bit of a motivation for where sort of the traditional place where limits pop up, although they come up all the time. So let's dive in, and I want to talk about a secant line. So a secant line is a line through a function that passes through 2 points. So I'm just going to do a generic, here's some generic function, I don't know. And if I want to pick these 2 points, so 2 x values, got different colors, let's use them. And we get that. And you might argue this this goes through 3 points. That's true. That's not the one I'm interested in. I want to pass through that point and that point. It happens to pass through a third as well. But so that's a secant line. Okay, so let's take a look at this. So let's find the slope line through x equals 0. So let's do a pretty straightforward function, f of x equals x squared, and then I'm going to pick 0 and 1. So let's go ahead and do a picture. Here's 0, here's 1. So red's on the ground. So that's what I'm looking for. Okay, and then those of you that are pretty quick at this, you can probably see what the answer is going to be. All right. But remember, slope of this, again, it's rise over run. All right. And I'm going to write this out like a lot of detail. So it's the function value at 1 minus the function value at 0. That's the rise. Rise over 1 minus 0. Right. And so if I plug this in, I get 1. I'll put, and I just get 1. So 1 squared, 0 squared, and then 1 minus 0. So I get 1. Okay. Okay, now, that seems great. Here's what I'm going to do, though, is let's generalize, and you'll see a little bit if you can just go with it why I'm going to do this. But I'm going to switch to a secant line through f of x is x squared, x equals a, and x equals 1. Okay. So here's what I'm going to do. Is I'm going to pick 1 here, and I've got some generic point A. Okay. Okay, and I'm going to have a little demo in class with this to actually use that Desmos tool to actually grab and play around with it. But there's some good stuff we can do with that. But we got that. Okay, but the point of this is I can basically I can grab and move around. So this might be 1/2. I could do maybe 3/4. I could do -2. I could do 7 over here. Anything I want to. So now it's still rise and run. If this helps, here's a little triangle. All right, so the rise is just f of 1 minus f of a, and then 1 minus a. And this seems a little bit crazy. If a was bigger over here, you might think, well, wait, you got to flip everything. And you do, but you don't, because you have to flip the top and the bottom, which everything stays the same, which is really kind of cool. So don't worry about the order of these points, as long as you're consistent top and bottom. Okay, right? So in this case, again, I'm just going to plug in. It's just that. Okay. All right. Now, why are we doing this? Well, if you imagine taking A and sliding it all the way over to 1, you would get a line that's called a tangent line. Basically, a tangent line touches only once. So let's write that down. So in this case, it would look like that. Okay. And now how are we going to get this? Well, the idea would be, right, all you do is I've got my formula for a secant line. Well, I just plug in A to be 1, right? However, if I plug in A equals 1, right, it doesn't work because I'm dividing by 0. But this is the key to this. We're going to use the limit. Okay. So the slope is the limit as c approaches, as x approaches c. Yeah, let me put it here. Okay. So I think I got enough little room in here. So what would we do? I'm going to say the m, and I'm going to say m sub t for slope of the tangent line is the limit as, in this case, a is my number and c is 1. This is the confusing thing, I know. I've got x's and c's and a's and all of this stuff, right? But I picked x to be a, right? And then c is 1. Okay, so I'll do a general formula and it hopefully will help out a little bit too. 1 minus a squared, 1 minus a. Okay. This is actually the same one we did in one of the previous videos. It looks a little different because we use x's instead of a's, but everything else. So from table, this is 2. Okay. All right, so I'm going to write down a couple of general formulas, which are quite nice for this. Okay, so the slope of some tangent line through some function is this. So again, mt is going to be the limit as x goes to c of what we've just been doing. So f of x, f of c, x minus c. Okay, so I've got rise over run between 2 points, x and c, and we get that. All right. Good. So let's write down the slope of the tangent line of y equals sine x at x equals 0. Okay. So lim x goes to 0. This is going to be c. Sine x sine 0 x minus 0. All right. And I'm going to tell you this is 1, and this is going to be from a table. They actually did this function in the textbook as the very first example of the textbook. So you can go back and look at that if you want to, but you get that. Okay. So that's what we got. Okay, so that is stuff about secant lines and difference formulas. I should have said this is a difference formula because it's the difference of two things. I should have said that, but apologize.